not greater than 0 and not greater than 1. That is the range of values of PA. It means PA lies between 0 to 1. Sum of the probabilities of all mutually exclusive and exhaustive events is 1. So we can define PS equals to summation of PEI equal to 1. The third rule is complements, that is probability of not A. We can define PA dash. PA dash equal to 1 minus probability of A. In the fourth rule is intersection. Probability of both A and B. So P intersection A intersection B equal to N A intersection B upon N S. Here S is a sum, right? The next property is union. Probability of A or B or both. So P A union B equal to N P N A union B upon NS equals to PA plus PB minus PA intersection B. The next rule is mutually exclusive events. PA intersection B equals to 0, so that we substitute this value and find the PA union B equal to PA plus PB. So we are define here continuous table of probabilities. The probabilities continuous are according to this table. We can consider PD, PB and also called as joint probability or simple probability. So their sum is total is 1 only. So you according to this tables you consider how to calculate the values. Now examples computing probabilities. In this example, event is red. The probability of red equal to number of red upon number of S. S is total sum. So number of red is total in the deck of 52 cards. 26 are red and total card is 52 to 1 by 2 event for red. But suppose I consider the event queen of hearts. So you know that queen and hearts also the deck is also considered as heart and queen. So we consider P hearts intersection Q. So 1 by 52 is possible. But I want to only hearts. So you know that in the deck of 52 cards, 13 are hearts. So we consider 13 upon 52 equal to 1 by 4. Same case we consider in the second part event queen. You know that in total 52 cards there are 4 queen is possible out of 52 cards. So 4 upon 52. And suppose I want to hearts and queen. So we consider the union because hearts how many possible and queen intersection is possible, that is 16 upon 52, that is 4 upon 32. Right. So the next definition is conditional probability. In the conditional probability example is some conditions is required. The probability of chocolate is 70%. This case is considered in the ice cream. You see the diagram. P chocolate is 70% and chocolate and strawberry is 35%. So what is the conditional probability? Conditional probability, because strawberries depend on chocolate. So PA conditional B equal to PA intersection B upon PB. But it is known, you know that PB not equal to 0. This is the conditional probability example also explained in the conjugation table. You check the table. According to table we calculate the conditional probability. Now what is the relation of and or, and consider union, and in the set theory we consider intersection and mathematical treatments are X. Same case in the union, right? Now rules of conditional probability. P A conditional B equal to P A intersection B upon PB. So you calculate according to given formula. Further, if events A and B are statistically independent, so how to calculate this value? PA intersection B equal to PA, PB intersection A equal to PB, and we substitute in this formula. So we can calculate PA intersection B equal to PA into PB. The next theorem is a Bayes theorem. What is the Bayes theorem? A method by which we might judge concerning the probability that an event has to happen in given circumstances upon supposition that we know nothing concerning it, but that under the same circumstances it has happened a certain number of times and failed a certain other number of times. This is called Bayes theorem. How to simplify it? How to understanding? So we take one example here. Diagnostic cases. We often know that P, probability of symptoms conditional to disease. The probability that you have the symptom given the disease, because this data has been collected from previous confirmed cases. So how to calculate the probability of disease condition to symptom? The probability of disease given the symptoms. So this is the example of Bayes theorem, and Bayes theorem used to reverse previously calculated probability based on the new information. According to decision tree diagram, you check how to calculate the Bayes theorem. The Bayes theorem interference is P A conditional B is a posterior probability equal to P B conditional A likelihood functions into PA prior probability, and upon PB is a marginal likelihood or normalized constant. The law of total probability and Bayes theorem. So this is the law of total probability and Bayes theorem. They are mentioned in the PPT. The law for total probability PA equal to PA intersection B plus PA intersection B dash. Same thing in terms of conditional probability, PA equal to PA intersection B plus PA intersection B dash. Okay, more generally, whereby make up partitions PA equal to, you can calculate according to this formula. Now we take example. Suppose in a stock market will go in the next year, that is the one event, it is called U, and event W economic will do well in the next year. So we check what is U, is a stock market going in the next year, and what is W, economic will do well in the next year. So the conditional probability I am apply here, the data is given in front of us. PU conditional W 0.75, 0.30 and PW is 0.80. So we know that how to calculate PW dash, 1 minus 0.8, that is equal to 2. So we can apply the formula of Bayes theorem and simplify the values. The Bayes theorem is this, and according to this we calculate this. There are so many examples are given. One case also I am discussing a medical diagnosis problem. So how to diagnose the medical treatment, how to do the, this is symptoms of dengue or malaria or any disease. So this example explain how to calculate the medical diagnosis problems. So these problems you show everything, calculate, I am here, and substitute the value and find the total disease, and T represent test is negative or positive. So test is positive, to calculate according to formula and find the data and find the result. So this data we can represent according to decision tree. The decision tree is a very helpful for computer science person understanding what are the results are given. So with the help of this result we calculate the values. Now I summarize what today I am teaching. Introduction to probability. We have covered what is probability, application of probability, why learn probability. Second, I also explain important terms, trial and event, different types of events. And third, types of probability, simple, joint, conditional, rules and relation, and Bayes theorem. Thank you.